Sixth grade, hopefully my voice hangs in there. Today we talk about igneous rocks. If you remember from Monday, melt, turn into liquid rock, cool and harden, and you have igneous. We're going to go through that today. How does igneous rock form? We just talked about it, so hopefully you know. It forms when molten material, lava or magma, cools. Does this happen in only one way? No. There are intrusive igneous rocks. Think about the word and look at in. Intrusive happens inside the earth. There are extrusive. If you look at this first part, looks like the word exit. When you exit a building, you go outside. These are outside the Earth's surface. Actually, you can find them both other places, but it's where something special happened. Intrusive igneous rocks cooled inside the Earth. Extrusive igneous rocks cooled outside the Earth. And here's what we mean. It forms when magma cools below the Earth's surface. See? Inside the Earth, below the Earth's surface. And now, since you're all smart people, you'll know with the extrusive, forms when lava cools above the Earth's surface. This can even be in the presence of water. That's above the Earth's surface. There are visible crystals within this group. Those visible crystals are pretty to look at. No visible crystals. Now, the next one tells us why there are visible and not visible crystals. All right? Large mineral grains because they cool slowly. When they cool slowly, it also has ideal conditions for it to have visible crystals. So if these cool slowly, we probably know that these have a very fine grain because they cooled quickly. Side by side, so hopefully you remember we are comparing these. Now, volcanic glass. It includes 3 different rock types. Pumice, obsidian, and scoria. Pumice and scoria over there are very light. You can see all the holes. There's lots of air pockets. Obsidian, very dense, very shiny. And if you remember from your 6th grade world history stuff, they used these for mirrors and blades and other things back in those primitive and ancient times. All right? But they all come from volcanic material hardening. Some have even been known to be able to float on water. Now, classifying igneous rock. Where they form is a big thing. Whether they're intrusive or whether they're extrusive. It's a big deal. Their type of magma. What makes them up? Where they form? Extrusive. They formed above the ground. Intrusive. Under the ground. So if we're extrusive, fine grains, no crystals. Intrusive, crystals and large grains. Type of magma. Basaltic, andesitic, and granitic. We dealt with these when we talked about volcanoes. The type of magma affects the mineral composition, so that's the density, the color, and the melting temperature. That's why you can have so many different colors of rocks, because the impurities, the density, the color, they're all affected by what is inside it and what type of magma that came from. Is all mineral composition the same for igneous rocks? Hopefully you realize after what we just said. No, it is not. So I can have extrusive basaltic rock. I could have extrusive igneous rock, or andesitic rock. I could have extrusive granitic rock. I could have intrusive basaltic, intrusive andesitic, and intrusive granitic rock as well. It's a way for us to classify them. Page 96 is a good page if you want to kind of look at classification of rocks. They've got a very nice picture there. I would really suggest checking that out. Here's a concept map of it broke down. Igneous rocks are into 2 groups. Extrusive, above ground, fine grains, no mineral, visible crystals. Intrusive, underground, large mineral grains, and visible crystals. Now we look at this and we can take these and you follow these lines. we break them down. There could be extrusive basaltic, dense, dark, low silica. Extrusive andesitic, it's between extrusive granitic, light, less dense. Oh, we have 3 gradients. Intrusive basaltic, dense, dark, low silica. Granitic, light, less dense. And andesitic is somewhere in between. All right. The big difference you notice between these 2 groups, and then the basaltic, andesitic, and granitic, they kind of stay the same, but this group will have fine grains, no visible crystals. This group will have large grains and visible crystals. So it's a way to kind of break them down, think of it in another light. Compare granite and obsidian. Mineral grain is different. Do you notice the different minerals stuck throughout here? This seems to be all one plain mineral. Visible versus no visible crystals. You cannot really see the crystals here because of the way the picture's taken, but you see some hints of them. You don't see, it's all one thing over there. And they're still both examples of igneous rock. One would be an extrusive example. One would be an intrusive example. Large grains. Oh, you can see the grains there. And visible crystals, those few. Fine grain. No visible crystals. But both are still igneous rocks because they melted and they cooled. One inside the earth, one outside the earth. One had probably an andesitic type background. One had a basaltic type background. The dark color tells me that. The mixture of colors tells me andesitic. All right, that's everything I've got. Hopefully that helps you get through your sheets. I'll see you all later, hopefully.